I am recording. Cool, guys. I'm a little, not too much, but a little under the weather. So we'll see how long the class goes. Today's class, if you've not gone through yesterday's class, it'll be slightly difficult. I wouldn't say it'll be too difficult because we'll be reintroducing everything. But this was yesterday's class on advanced backend communication and WebSockets. Today's class is on. We need better search over here. Today's class is on Redis, pub subs, and messaging queues. So let me share the link to the slides. But yeah, if you did not go through yesterday's class, today's class might feel overwhelming at some points, but I'll try to take everything from the basics. Just to give a brief about yesterday's class, yesterday we understood how do you do advanced backend communication. More specifically, how does one backend system talk to another backend system? This is something we did yesterday. I sort of introduced pub subs as well as messaging queues yesterday. Today we're diving deeper into pub subs and messaging queues. What did we discuss yesterday? HTTP we already know. WebSockets we discussed yesterday, even though WebSockets aren't really used for backend to backend communication. They are usually used for front end to backend communication. Pub subs and message queues are almost always, always used for backend communications, for two different backends to talk to each other. You will never have a browser over here publishing directly to a pub sub. You will never have a browser, most probably, unless I'm missing some very weird use case, publishing directly to a message queue. It is for communication between one backend and another backend. Harkirat, can you give me an example? We gave two examples yesterday, a Paytm example and a LeetCode example. Today, we will dive deeper into the LeetCode example. What are we learning today? We are learning queues, pub subs, and Redis. If you want to code along, you will need Docker on your machine because we'll be using Docker to start Redis. So if you don't have Docker, might feel a little, you might not be able to code along. You can still figure it out by getting a Redis instance online on, Avian or some other provider. But I would just say use Docker because even if you use Avian, you will still not have a few things locally that you might need. So please make sure you have Docker installed. And what are we learning? Queues, pub subs, and Redis. More specifically, we are learning how would you build a system like LeetCode? How would backend communication happen in a system like LeetCode? Where does a queue come into the picture? Where does a publisher subscriber come into a picture? Harkirat, then why are we learning about Redis? Because Redis gives you a bunch of things. Two of those things being pub subs and queues. Harkirat, can I do pub subs without Redis? Yes, you can. There are many projects or, libraries or implementations that let you do pub subs. What is the name of that? I'm forgetting. Queues also, there are many implementations. RabbitMQ is a good example of queues. What is a good example of pub sub? Is SNS a good example of pub sub? Probably. Simple notification system. Someone can notify, other people can listen on to notifications. Maybe not technically true. SNS is a service by AWS. But if not SNS, there are various, pub sub implementations. Redis is one of them. Redis lets you do pub subs. What are pub subs, Harkirat? We will get to very soon. Let's understand, in a LeetCode like system, where do you need queues and where do you need publisher subscribers? The first part, the final architecture of LeetCode is sort of complex. This is the final architecture. Before we reach the final architecture that has both the pub sub and the queue, let's just look at a simpler example with just the queue. The architecture says, anytime the user is on your platform, for example, the user is on leetcode.com and they try to submit a problem. Let's say I open the toSum problem over here. Anytime I try to submit the problem, a request should go to the primary backend of yours. Harkirat, what is the primary backend? your Express server, simple Express server that received a request from the browser. Okay, bhai, for problem ID 1, or in this case, it will be problem ID 2-some. Code is some code snippet. In this case, the code snippet would be this. And then the language in this case is Python. But here, whatever the input might be. This input reaches a primary backend and this pushes it onto a queue. Harkirat, why does it push it onto a queue? We have the code of the user. We should just execute the code of the user here. Tell them the response. Ki yaar, there you go. Your code succeeded or failed. The problem is, the reason you need to delegate this out is that what if the user sent you a code that's malicious? What if they sent you something like this? While one, or whatever is the way to do while loops in Python, C++, C equal to 0, something like that. What if they sent you code like this? You will take their code, run it on your primary backend, the CPU of your primary backend that is supposed to serve other users is now being used to run the user's code, which is why you delegate the user's code to someplace else. You say, "Ke bhai, acha, your code will run someplace else. Let me take your code and send it to that worker." That is why it says W1 here, because this is a worker node. Why is it called worker? Because its job is to work on something, to pick things, do its thing, and then, respond back, and then pick the next thing, do its thing, respond back, so on and so forth. Hence, usually these are called workers. The primary backend puts this onto a queue. It puts your problem onto a queue, and your workers pick problems from a queue. Harkirat, why do you need a queue? Why can't my primary backend simply tell worker 1, "Ke bhai, please execute this code"? That way I have delegated. It is not running on my machine. There is no security issue. The reason you cannot do that is because what if 100 people send you requests? If 100 people send you their code, you don't want to send them to, the same worker, which only has 4 GB space. You want to guarantee, whenever you're on LeetCode guarantees, okay, your code is running on a 2-core machine with this much CPU, so on and so forth. You have to make sure those guarantees are met. You have to make sure every worker runs a single code at a time. And queues become a very popular use case in this case. Okay, even if you have only 2 workers and 20 people submit problems, you will have a long queue. And workers will pick them up slowly. A lot of people will be waiting for their response. But you can guarantee that worker 1 will only pick 1 item at a time. Worker 2 will also only pick 1 item at a time. It will run it. It will store the final response somewhere. And then it will pick the next thing. So to make sure you pick things one by one, to make sure if your primary backend is overwhelmed, if everyone is trying to do a very expensive operation very fast, you can smoothen out that operation. Okay, bhai, let me push to a queue. Slowly we will do it. If you submit on LeetCode, take some time, test results, because there's a asynchronous backend process that's processing your code. That is where you need queues. Another benefit of queues is if you have 0 workers, then also at least, people's submissions remain in queue. Whenever you bring up a worker, they start to get picked up. Another benefit is you can auto scale your workers. You can be like, if the queue length becomes 100, I should probably start 20 workers. But if the queue length becomes 3, I should probably stop most of them. Only 1 is fine. So you can auto scale your workers up and down. This becomes super important because in LeetCode, if there are 100 people on your platform, you don't really want to bring up or keep 100 workers alive at the same time. These are very expensive machines. So you have to make sure you auto scale them very aggressively. Queues are a good use case for it. So that is one place you might want to use queues. Generally, whenever you have an expensive operation that needs to run on a single machine, another good example of this is video transcoding. Harkirat, what is video transcoding? If I go to YouTube and upload a new video, it takes some time for the video to process. I upload a single 1080p video. That video gets converted into 4-5 different qualities. This is called transcoding. This is also a very expensive operation. Here also, you want that whenever there is a user uploads a video on YouTube, it goes into a queue and then workers eventually pick it up and transcode the video. So that is another use case where a queue makes a lot of sense. A good example of queue is RabbitMQ, SQS, simple queuing service in AWS, or Redis also lets you do queues. And the second part that we have to learn is PubSubs. So quickly to revise, what have we learned? Whenever you have users who want to do an expensive operation on your machines, a long running expensive operation, be it submitting a lead code question or uploading a video for transcoding, for converting into 720p, 360p, you probably want to use an architecture like this. You probably want to upscale and downscale workers based on the length of the queue. That is where you need queues. Where do you need PubSubs or publisher subscribers? Even before that, what are PubSubs? What is a publisher subscriber? The name is sort of self-explanatory. Let's look back at our example. User submits some code, sends it to the primary backend, sends it to the queue, gets picked up. Once it is picked up, the worker needs to tell the browser, right? Okay, you have accepted, you have rejected. It needs to send the final result to the browser. If you remember from yesterday, how does LeetCode do this? LeetCode uses polling. If I right click over here and click on network and click on submit, you will see after the submit request goes through, it starts to send a /check request again and again and again and again. It starts to poll the backend. Is it done? Is the submission done? And once initially it gets pending, and then eventually it gets कि भाई it failed for this specific error. So LeetCode uses polling. But can you do something better? Can you use WebSockets, the thing that we had learned yesterday? Harkirat, what is the benefit of using WebSockets here? If you use WebSockets, the browser won't constantly poll the backend. Ke bro, hua kya? Is it happened? Has it happened? Has it happened? It won't overwhelm your primary backend, which will in turn overwhelm your database because at every step here we're writing to a database as well. I have not kept it in the diagram for ease of understanding it, but whenever you make a submission, an entry goes into the database that says this problem is processing. Whenever the worker is done with it, the worker updates the entry ke this problem has been accepted or rejected. So there is a database here. We are not looking at it. But when the user is long polling, then they're overwhelming the backend again and again. Okay, bhai, please give me result, asking it 10 times. What if the server could push? Okay, bro, I am done. Your submission was a TLE, a time limit exceeded, and tells the browser so the browser can show it on the front end. For this, for pushing events from a server to a client, what can you use? Something we discussed yesterday, WebSockets. So what can happen after the worker is done? After the worker is done processing your code, getting the response, checking if it is correct, it can send the response to a WebSocket server, which is connected to the browser. Whenever I go to leetcode.com, what if there is a persistent connection to a WebSocket server? And whenever, if I'm on this page, what if there is along with the HTTP request that I'm sending when I click on this, there is a persistent connection to a WebSocket server. Anytime I click on run, and the worker finally processes it, the worker can signal to the WebSocket layer, कि यार, please tell user with ID 1, if he's connected to you, if the user with ID 1 is connected to you, tell them that the status of their recent submission was time limit exceeded. That is how a worker can talk to a WebSocket server and publish an event to the browser. Harkirat, why did you not use WebSocket layer here? Why did you not use messaging queues here? Why did this guy not directly talk to this guy? Why can't worker directly talk to the browser? Why are you complicating it with so many services? Good question. A lot of questions. Let's answer one by one. Worker can never directly connect to a browser. Workers are very transitory. They come up, go down. They should never be exposed over the internet. The worker's job is कि bro, give me a code, I will run it, and I will put the entry in the database. ज़्यादा से ज़्यादा, I will publish to a pub sub. That is all. I will not do anything more. So the worker's job isn't to connect to a user. Workers anyways go up and down very quickly. So you don't want your end user to connect to a worker. So you have a fresh service. What do I mean when I say service? Another Node.js application that the browser connects to. Your browser is connected to this WebSocket layer. And whenever the worker completes the submission, it can tell a pub sub, okay, yaar Hakiyat, whoever has user ID 1, please send them this specific status for their submission. Why do you need a pub sub, Harkirat? Why can't this worker directly talk to the WebSocket layer? Great question. This is a beautiful question. Okay, yaar, why do you need a pub sub? Why can't worker directly tell the WebSocket layer? Okay, why tell the browser? Okay, his problem is done. This guy can talk to this guy via HTTP. Why does it need to go via a pub sub? And the answer is something we discussed towards the end of yesterday's class. Okay, in the real world, you have a fleet of WebSocket servers. You don't have one WebSocket server. One WebSocket server can only support 10,000 users. You have multiple WebSocket servers. And your user could be connected to anyone. They could be connected to, let's say, a persistent connection to WS3. So whenever the worker is done, it doesn't know, okay, should I send this information to this guy or this guy or this guy? So what it can do is, it can publish an event to a pub sub, and then whenever a user connects to a WebSocket layer, I repeat, whenever there is a WebSocket connection between a user with ID 1, let's say, and a WebSocket server, it can subscribe to an event called maybe, user ID 1, something like that. This guy can subscribe to an event called user ID 1, and the worker can publish. If the worker knows that this submission was for user ID 1, it can publish to the pub sub, okay, user ID 1 has this submission. That way, this worker can directly reach the WebSocket layer versus trying to figure out, ki, Achha, are you the person who's connected to user 1? Achha, you are not. Are you the person? So on and so forth. This guy's like, I will publish to pub sub. Whoever wants it, please subscribe from here. It might happen that you have, two browser tabs open, or, you have a mobile app open, and the mobile app is connected to WebSocket 1 server. You share a lot of LeetCode accounts. You might have a friend who's in Maharashtra. You might be in Chandigarh. You are both sharing LeetCode accounts. He submits. You should still receive the notification. Ki, haan, your recent submission was successful or failure, let's say. So, multiple WebSocket servers can subscribe to the same event. And then this single event goes to person in Maharashtra as well, person in Chandigarh as well. Harkirat, why do both of them need? Only one person will be here. Assume there is a use case that whenever you make a submission, a notification comes here that says, Harkirat, you have a successful submission, irrespective of if you have this page open or not. So if your friend in Maharashtra is on LeetCode and you make a submission here and it is successful, they should also see a notification here. As long as it's the same account, you guys are sharing an account, they should also see a notification here that says, okay, Harkirat, something has happened. Now I will take a pause because I feel I'm connected to a VPN, which I shouldn't been. But let me just take you through the final thing, the final architecture one more time, and then I'll take a pause. But this is the brief of a publisher subscriber system where, in this case, a worker publishes to a pub sub and whoever wants can subscribe to the pub sub. If we had a single WebSocket layer, then the worker could directly talk to the WebSocket server. But since we might have a fleet of them, you probably want to go through a pub sub. Cool. This is what the final architecture looks like. There is a browser over here that sends the request, reaches the primary backend, goes to a messaging queue. Whenever the worker has the time, it is doing its thing. Let's say there are only two workers. He'll first pick this one, then this guy will just pick this one, then will pick this one. They'll sequentially pick up all of them. Whenever they pick a problem and they find the final solution, whether it's an AC or a TLE, they tell a pub sub that user ID 1 has done something. Whichever WebSocket layer user ID 1 is connected to receives this via the pub sub and sends it back to the browser. That is a brief of the architecture for today. That is where you need messaging queues and pub subs. Now let's do a poll. Did we understand this to begin with? Yes or no? Only 77% understood, which is fine. We will do recap very soon. Second question is my internet good? Yes or no? It's good. All right. So let me look at Q&A really quickly. Let me spend maybe 6 more minutes on the architecture before we proceed to coding. After this, it's just a bunch of coding, understanding Redis, understanding how you can create a pub sub, a queue. Any specific question? Could you repeat the architecture? Let me try to repeat the architecture of something like LeetCode. Let me recap it. Let's build the ugliest version of LeetCode, the one that you might have seen on some other YouTuber's website that was hacked by someone, I don't know whom, not me. The ugliest version is, this is my EC2 machine. This is running a Node.js process. And some user comes and sends a request. Okay, I want to submit a C++ code that looks something like this for user ID, whatever. I'm user ID 1. The ugly version says, okay, our Node.js process will spawn another C++ process and run the code. What is the problem here? Why is this approach ugly? This approach is ugly because the C++ code could look like this. While one, do something. Then your server is choked. You are letting a malicious user choke your server. What else can the user be writing in C++? They could write something like this, system of ls. The user came to your website, selected C++ as the platform, and wrote the code that looks something like this, system ls. They can explore your file system. What does this do? It runs the command ls on that machine which is running. And if you're running it natively on your EC2 machine, then this C++ process that you're starting, the final output will get returned to the user in the browser, and they will be able to explore your .env files, your MongoDB URL, your Postgres URL, so on and so forth. This is exactly what happened with one of the websites I was exploring. I was like, I can find a MongoDB URL here. So what is the learning? This is the ugly approach. Harkirat, what is the better approach? The better approach is, this machine doesn't run anything. This is your primary backend. You don't want to run any external code here. You want it to run on a different EC2 machine. But the problem is, how do you know how many EC2 machines you need to have? Should you have one EC2 machine? Yes, Harkirat, one is good enough. What if 20 people submit at the same time? How will a single EC2 machine handle 20 submissions? It cannot, which is why what you can do is you can maintain a queue. I am Garib. I have just started LeetCode. I am self-funded. I am bootstrapped. I don't have funding. I only have a single EC2 machine. If more than 20 people or 20 people come to my website and submit, they will slowly see the response. If 20 people click submit, first person will immediately get it. Second person will get it in a while. 20th person will get it very late because they are one by one getting picked by my worker. And this worker is on a separate machine. If the user's code looks like this, it's fine. It's running on an empty machine. This machine doesn't have any code. If the user code has a while one, then we can, this machine gets choked for 1 second. We can always, of course, have a timeout. If the code of the user takes more than 1 second, then you TLE it and you say the problem solution was TLE or time limit exceeded. So one by one, it gets picked up. That is why you need messaging queues to make sure if 20 people come, your expensive operation can still be handled by a single machine. Of course, if this queue becomes really long, then you should ideally scale up the number of workers that you have that are running the end user code. That is the first part of messaging queues. What is the second part? Second part is once this guy is done solving a problem or, solving the end user's code, which let's say looks something like this, it reached this worker. It was able to solve it. It needs to tell back the user, you have a TLE, your code looked like while one, you have a time limit exceeded. How can this EC2 server talk to this user? There is no easy way. Either this EC2 server puts an entry in your database कि यार the submission ID 1 status is TLE. Either we do this, okay, whenever the response is done, EC2 will set this in a database and the user is polling, okay, yaar, is my submission done? Is my submission done? And then this Node.js process is hitting the database and getting back your status. This is called polling. This is what LeetCode actually does. LeetCode actually does this. We just saw it in action. It was polling the server again and again. This is one approach. This is easy. This does not use pub subs. Why do you need pub subs? Okay, if you are using WebSocket servers, if you have a fleet, what do I mean by fleet? I mean multiple WebSocket servers that you can use to, push events to the client. Your user will randomly connect to a WebSocket server. And when it does, it can tell a pub sub system, a publisher subscriber system, okay, yaar, I have user ID 1. If you have any information related to user ID 1, tell it to me so I forward it to him. This guy is very interested in his own feed. If there is any real-time feed, if there is any submission that has been accepted, if there is any, TLE that has come, tell me so I can forward it to him. And then the EC2 worker will of course put this entry in the database as well, but will also tell the pub sub, okay, yaar, user ID 1 just got a submission done. It was a time limit exceeded. Please let them know. And then this event can reach WebSocket 2. Another reason for having a pub sub is, what if, there is another feature in LeetCode. If you're on LeetCode, there is another feature. Okay, whoever is live on LeetCode, there will randomly be a bounty here. If you do more LeetCode, if you are active on LeetCode all day, you will randomly one day see claim $5 or claim premium and you can click on it. Let's say LeetCode introduces this. Okay, if you are very active on LeetCode, randomly throughout the day, we will have a lottery and it will come for whoever is currently active on LeetCode. If they want to add a feature like this, all they have to do is again publish to this pub sub. Okay, bhai, irrespective of user ID, like user ID any user ID, please send the lottery button so that whoever is currently connected, whoever is currently on this website will have a persistent connection to the WebSocket layer, be it this one or this one, doesn't matter. And you can say, bhai, WebSocket 3 and WebSocket 2 and WebSocket 1 will all subscribe to the event user any. If there is an event that comes for user any, it will reach all of them. And then, they can forward it to everyone. This might have gone, above your head, which is fine. If you did not understand the lottery use case, it is fine. I just wanted to show you how you can have multiple publishers also and multiple subscribers also. But right now, let's keep it simple. Let's forget the lottery use case. The simple use case is the worker tells the pub sub, this person has a TLE. And if the person is currently active on the website, then the specific WebSocket layer is subscribed to that pub sub. If there is no user with that ID, then this guy will publish to the pub sub. No one will pick it up because this user isn't even active. If this user isn't active on the website, you don't have to send them the event. Whenever they come back, they will refetch their submission directly from the database. That is how you do message queues and pub subs in LeetCode. But the thing to understand is architectures. The first set of architecture remains the same. If you're building a YouTube transcoding website as well, or so YouTube transcoding system as well, the second part of the architecture remains constant. If you ever want to have a pub sub like implementation, there are use cases of it. Chat is, if you remember from yesterday, I told you if you want to ever scale chat, then also pub sub is a decent way to do it, but you can go to yesterday's video and look at that. Now let me do another poll and see if this revision makes it a little bit clearer, because if you understand the architecture, writing the code is, not too difficult. It's actually fairly straightforward. %, good, not great, but I think I should proceed now. And for the people who do not understand, try to understand pub subs and implementations of pub subs and queues. You can worry about this architecture later on. Let's learn Redis. This slide has nothing to do with the last slide. So if you did not understand the last slide or specifically the architecture, it is fine. Let's understand Redis. What is Redis? You might have heard this as, a very big buzzword. Redis is an open source in-memory data structure store used as a database, as a cache, and as a message broker. Harkirat, used as a database. Is it SQL database? Is it no SQL database? Why have we never used this? Why did you never introduce Redis as a database to us? Why did we only worry about MongoDB and Postgres? The answer is, even though Redis lets you store data, you should never use it as your primary database. Harkirat, why? Why should I not use Redis as my primary database? There is a video at the end of slide, some slide here, whenever it comes, that explains this in very good detail. It's a 20-minute video. There you go. It's called, I've been using Redis wrong this whole time. It will show you if you really want to use Redis as your primary data store. You can, but it will make your life very complicated. Harkirat, if you cannot use it as a database, why did they even introduce Redis? Then you don't need Redis. What is the use case of it? The use case is Redis is used aggressively for caching data. Harkirat, what does caching data mean? Caching data means if you have a website, and let's say this is the browser. Let's take an example of a website. Let's say take the website Daily Code, the website that we are on, projects.redexdevs.com. It has, let's say, 20 tracks like these. Whenever you come to the landing page, assume this is a simple React plus Node.js application. Nothing too complicated. React plus Node.js plus Postgres. Whenever your browser sends a request to, let's say, the backend, okay, bhai, get request to get all the tracks, the Node.js backend then forwards this request to a database, your Postgres database, gets back the response, and then returns it back to the user. What if 100 people come to your website together? Then you are sending 100 database calls. What if 1,000 people come together? Then you are sending 1,000 database calls. How often do you think this page changes? This track only gets added on one on Saturday, one on Sunday, and now one on Tuesday, one on Thursday for DSA classes. That is it. If this never changes too often, do you really need to hit the database? Harkirat, yes, I know the answer. Static site generation. No, static site generation is for Next.js. This is simple Node.js backend. Here the answer is caching. You want to cache the data. Harkirat, what does caching mean? It could mean many things. You could yahan pe in memory have a variable called tracks, and then only the first time the user asks on this endpoint, should you hit the database? And then you should just cache it in memory. Harkirat, what does in memory mean? It means, put it in as a variable in your Node.js process. Okay, I got the values from Postgres. However, you would get it like prisma.tracks.get or find first, whatever your request was, const tracks equal to this. Then just do a, globals.tracks equal to tracks, or, cache this request in memory. In memory means in the Node.js memory. You can do that. And then all future requests for the next 10 minutes, let's say, you can serve directly from here, from your Node.js backend. You don't have to hit the Postgres database anymore. You can cache them for 10 minutes, let's say. That is one thing you can do. Or you can cache them in Redis. Harkirat, why would I cache them in Redis? I will just cache them in memory. There are a few reasons. Firstly, what even is Redis, Harkirat? Like, what do you mean cache it in Redis? As I said, Redis also lets you store data, right? So why not first time send the request here, get back the response, and cache it to Redis. And then in all subsequent requests, just get it from Redis. Harkirat, if 100 people come, I'm still hitting Redis 100 times then what's the benefit? I will hit Postgres, I will hit Redis. Redis is a in-memory, provides in-memory storage. Harkirat, in-memory storage, it is running a process very similar to a Node.js process here, where your data is stored in memory. So it's very fast retrieval compared to your primary store, or Postgres or MongoDB. That is why usually, very often, you will see Redis as a caching layer. Rather than caching in memory, you should cache on Redis. Another benefit of caching it on Redis is in a real application, you'll have more than one server because you'll have a lot of traffic. So you'll have a bunch of servers. You can do distributed caching. Akira, what does distributed caching means? It means if one backend server got the data from Postgres and put it in Redis, and now if another browser comes to the second person can also just check from Redis, or the second server can also just check from Redis and respond back. Versus if I had it in memory, then this guy's memory would have it, but this guy's memory would not have it. You would not be able to do distributed caching. But now you can do distributed caching because you have a separate Redis instance running, which has, in-memory data storage where you're caching your data. So that is the most popular use case of Redis. I don't know. I mean, this is debatable, but like the most popularly I've seen Redis being used in big companies or small is to cache data that comes from the database to minimize the number of requests that are going to the database. This is a decent example of, how Redis runs on your machine. As I said, it's a in-memory data store. You should ask a very good question at this point. Kirat, you are saying it is in-memory data store. If this is running on an EC2 machine, this Redis server or Redis process is running on an EC2 machine, you are saying it's in memory, which means it's similar to a Node.js process running here. What if the process dies? What if Redis dies? The data was in memory, then the data got lost because you said it's storing it in memory. The same thing would happen here. If you did not have Redis, forget Redis and forget multiple servers. If you have even a single server and you cache the data here in a variable called tracks, if your backend goes down, then this variable is lost. No, when you restart the process, you will have to hit the database and at least get it once. So in-memory data to gets lost. In-memory means it's in the process that is running. It is stored over there. It is not stored on a disk. So Harkirat, what if Redis goes down? Then all your data is lost. Firstly, if that happens, let's say if the data is lost, doesn't matter. It was cache data. It's not your primary store. Your primary store is still this. If this goes down and assume that the data also got lost, it's fine. It'll come back up as a fresh instance. We will recache the data over here. We are good to go. You had to hit the database a little bit more, but that is fine. So in case Redis did not, back up the data somehow to the file system, your life would have been sad. But Redis does back the data up into the file system. It still stores data in memory. If you ask for it, it'll immediately respond back with the data. It doesn't need to hit the file system to get the data. It has it in memory. You ask it for data, it'll return you the data immediately. But in case it goes down, it can recover back its state by doing two things. Two jargon to introduce, and very commonly used jargon in systems like these, where you need something to be in memory, but you also need to be able to recover it. I repeat, you need something in memory, but in case it goes down, you can recreate the state again. How can you do this? Let me give another example of this. Whenever you go to backpack.exchange and place an order, let's say you click on buy or you click on sell, or anyone clicks on buy or sell, this request goes to a queue. This request goes to a queue, and from this queue, it gets picked up and it's stored in a in-memory order book. Harkirat, what is an order book? Order book is this thing you see over here. Whenever you place a limit order, Harkirat, what is a limit order? Forget about it. Whenever some traders place some orders, for example, someone has placed an order, okay, I will buy one USDT or sell one USDT for 1.00003. And someone has placed an order, I will sell one for 0.0004. Traders place these orders. All of these orders are also in memory in a Rust process. They are not stored in a database. They are in memory, which means, literally a variable called order book equal to this thing, because this needs to be very fast. The order placement needs to be very fast. So here also, what if the Rust process goes down? then your order book was in memory. All the data got lost. So here also a similar architecture is used to Redis to make sure that if the in-memory thing goes down, you can still recover the state, the exact order book before it went down. Even though you're storing it in memory, if it goes down, you can recover it back. How can you do it? There are two ways. Way number one is, you maintain a queue of every event. Someone placed a trade on, an order to buy for this much and sell for this much. Since the beginning, all the orders that have been placed, you maintain them in a queue. And if it ever goes down, you just replay all of these events. Someone came and placed one order, removed one order, so on and so forth. You can replay all events and store them in a queue. Redis also lets you do the same thing. Redis lets you store data in two ways. Either a append only file, which means it will keep appending. You added this data, you remove this data in a very long file. And then whenever the Redis process goes down, if you have to bring it back up, you will take that file and, run all the events from top to bottom and be able to recover the state. That is one. You literally have a record of all the events since the beginning. If your exchange has been up for 1 year, you have the record of every order that was placed. You can replay that queue of messages and recover your in-memory order book. Can you guess the problem in this approach? The queue will become very long. What if this has been going out for a year? Whenever the order book goes down, it will take 20 minutes for the order book to come back up because it will replay all the billion events that have been here. How can you do something better? How can you make sure that thoda fast, if I was able to recover my order book, it would have been nice? And the answer is by doing something called snapshotting. You can snapshot the current order book every 1 hour. Hour number 1 of our exchange being up, our website being up, first hour the state looked like this array. And then, on 22nd Feb, 2 p.m, it looked like this. So you have snapshots every hour and you have the whole queue. You can take the latest snapshot plus all the events that came after and recover the order book. That is another way you can recover an in-memory variable. And Redis does the same thing. You can do a Redis database file. The RDB database file performs point-in-time snapshots. You can tell the Redis configuration, save 901, save the dataset every 900 seconds if at least one key has changed. What does one key has changed mean? It means some single thing changed in the queue. Someone, put some data in Redis or removed some data. If at least one key changed in the last 900 seconds, take a snapshot. So you have, snapshots of Redis at every point and you can recover the data from here. If you don't understand this, it's mostly fine. It might be asked in an interview, but it's good to know if you want to ever build something like this. If you ever want to build an in-memory data structure, why would you want to build an in-memory data structure? What do I mean by in-memory data structure? I mean, something that's stored in a variable in a Node.js process or in a Rust process. You want to do it because you want this system to be really fast. That is why you might want to do it. And what is the downside of this? If the backend goes down, if the Node.js process ever dies, your in-memory variable dies with it. So you need a way to recover. And how can you recover? Either you have a list of all the events since the beginning, or you have snapshots every 1 hour plus the events in the last 1 hour, let's say, or last 2 days. So you can recover using the latest snapshot plus all the events that came after, and you can reach back your order book state in memory. Do we understand how Redis persists data and how an in-memory data structure can be persisted even if it is not Redis? Architectures are very similar. In fact, a lot of this was Backpack architecture was inspired from Redis. Mm. 80%. Even if you don't understand this, as I said, it's fine. No one really needs to know the internals of Redis. I'm happy to take doubts at the end. In fact, happy to, it's 7:48. So let's take a break only. Wow, we've not done any implementation in the first 48 minutes. This is feels like a system design cohort now. Okay, so let's take a 12-minute break. I'll answer some questions. And until then, please run this locally. Make sure this works for you because, iske baad we'll start coding and you need Docker. So, you have 12 minutes, install Docker. Let me look at the thing. What if the queue dies before a snapshot was taken? Do you mean the queue is unstable and, if data gets missed in the queue, yeah, you're screwed. Your data is, you missed data. But generally, for example, in Backpack, first the thing reaches the queue and then the Rust process picks events from this queue. So it can never happen that something reached the Rust process and did not reach the queue. Everything first reaches the queue, and then the Rust process picks it up from there. Why don't you keep it in a hash map rather than using Redis? I've seen you're doing caching in CMS5 hash maps. Yeah, you can do that. As I said, you cannot do distributed caching then. If I have 2 backend servers, then you can't store it here. That is one of many reasons you might want to use Redis. What if you have a very big variable? Then if you're storing that very big variable in memory, your EC2 might run out of memory. Those might be the reasons you might not want to do in-memory hash maps, but it works. Like, you can still do that. Once a snapshot is taken, do we clear depends on you. You can clear the queue if you want. Redis, from what I know, does not clear it. Redis maintains the append only log forever. From what I know, if you enable append only log in Redis, it will maintain the log forever. Could be wrong, but I think so. Same happens for Postgres also. Postgres also has a concept of a write ahead file, WAF. Pretty much the same thing. Every event before it reaches the actual Postgres database, assume this is a Postgres database, it gets written to a file. What if the value in the database changes? Will Redis cache change? No, that is the question. Exactly, great point. Someone said, Kirat, you are caching data for 10 minutes. What if the database value changes? Then people will see stale data for 10 minutes. So usually what happens is, whenever there is a write, whenever let's say an admin comes and sends a request, add track, whenever there is a write event, you clear Redis as well. You send a request to Redis and you clear the specific thing so that whenever someone asks now, they get fresh data from the database. So another interview question, in case you're interested, now that you've ये topic छेड़ दिया आपने. If there is, get requests, you cache them in Redis, Kirat. Just make this cleaner. This was asked to me in an interview very early in my career. Let's say this is your architecture. Browser, there are 2 browsers. There is a user browser that is sending requests to get tracks. There is also an admin browser. I repeat, there is an admin browser that is adding new tracks. Whenever you see a new track being added here, there is some admin that goes to projects.analytics.com/admin/add, clicks a few buttons, clicks on submit, and a new track gets added over here. Now the question is, you made caching. Forget admin exists. If user sends a request, you cache it in Redis. Only one request goes to Postgres for the next 10 minutes. And after 10 minutes, the Redis cache gets cleared and then you re-ask the database. If on the 3rd minute, I repeat, if on the 3rd minute, the admin sends a request to add a new track, what should you do? You have 3 options. Option number 1, clear Redis, put data in Postgres. Option number 2, update data in Redis, update data in Postgres. Option number 3, update data in Postgres, followed by update data in Redis. From first principles, try to answer this. When the admin comes and adds a new track to the backend, you need to make sure that Redis gets the updated data, right? Else everyone will keep getting the stale tracks. The new track that was added, let's say, a DSA 3 tag was added, users won't see it for the next 10 minutes or the next 7 minutes if this happened on the 3rd minute. So you should do one of these 3 things. Either just clear Redis so that whenever the user asks for it, they get fresh Postgres data with your DSA 3 tag. It gets put to Redis. You get fresh data. Or you can update the data in Redis. A new DSA 3 track was added. Please keep it here. And then you can do the same in Postgres. Or vice versa. You can first send it to Postgres, then send it to Redis. What would you do? Option 1 or option 2 or option 3? Think from first principles. There is just a single answer for this. I will do a poll very soon, but the answer should be very obvious. What would you do? launch. Wow. Majority has failed. Most people chose option number 3. Some people, okay, second option is choice number 1. Choice number 1 is the right answer. And then 32% selected choice number 1, 42% selected choice number 3, 24% selected choice number 2. Choice number 3, 2 and 3 are wrong. Why? Because it might happen that this request succeeded, update data in Redis succeeded, and your backend server went down. Or in this case, it might happen, update data in Postgres succeeded and your backend server went down. You cannot guarantee that both will happen. Your backend server is very unpredictable. What if Redis is not responding this time? What if, the server went down is the best example. You updated data in Redis. You told the user, admin, that data update has been done, but you forgot to update the data in Postgres, or Postgres update failed for whatever reason. Then you have stale data in Redis, which will get cleared after 7 minutes or 10 minutes. And then, backend Postgres the data never reached. Same for this guy. One of them might happen, one might not happen, which is why the cleanest is clear the data in Redis. If the Redis data cleared, then store the data here. If clear Redis request fails, then don't do this. Just tell the admin, sorry, request has failed. But the first thing you should try is clearing Redis. After this succeeds, you should try putting data in Postgres. If this also succeeds, then you can tell the user, Harkirat, what if first succeeds but second doesn't? That is fine. If the first succeeds, clear Redis succeeded, put data in Postgres failed, you tell the end user, sorry, your update failed. Of course, you cleared a cache key, but that is fine. It will get refreshed in the next database call from the user. The problem comes when you're able to update one, but the second one fails. Then you will have to revert this. Here, I updated in Redis. Okay, DSA3 was added. And whoever is sending GET requests is able to get the data from Redis. But I forgot to, this request failed to update it in Postgres. I will have to revert this Redis request. We'll have inconsistent data. And same logic applies here. That is why, I'm hoping this is straightforward. Doesn't starting a new EC2 machine takes time? Do we use AWS Lambda to mitigate this or something else in infrastructure? So it does take time. There are a few options here. Number one, you don't usually use EC2 machines. You don't bring EC2 machines. You have a Kubernetes cluster where you bring up more pods. And bringing up pods or Docker containers is much faster than bringing up this thing. You have compute. You have 100 machines running. And as people come to your website and submit, you start small Docker containers. When we finish this lead code, we'll be doing this when we reach the Kubernetes part. If you're interested to learn about this right now, you can go to YouTube and search for my Replit video where I discuss this. But short answer is you don't start EC2 machines. You have a cluster. This is an auto scaling cluster which will have, 50 to 100 machines based on current load on Kubernetes, and you can go from here. How often would data be cached in Redis? Is there a possibility of data could be stale? If yes, why not use materialize use, which is either updated via a cron job or whenever the underwrite table is updated? Why introduce a new cog in the infrastructure, which is also expensive? What do you mean by expensive? Firstly, materialized views sounds super expensive in this case. You're saying create a materialized view anytime data is updated. Data is updated very often. If your, let's say this is your table and, a row changed over here, you are saying recreate the materialized view. Versus if, this is your Redis cache and, a data changed, you are just changing a single key over here in the Redis, data changed, you're changing a single key over here versus here you'll have to recreate the table. And what was your other thing? Cog in the infrastructure. And you can also say, Harkirat, why do you need any of this? Just do it in memory. Why do you even need materialized views? If this is your Node.js process, do it in memory. In fact, that is exactly what we do on app.100xapps.com. This tracks that you see, these contents that you see, or you don't see it right now, but you get the idea, are cached in memory. So yeah, you don't need it. I'm saying it's the most popularly chosen thing. Okay, you cache in Redis. Why is it popularly chosen? God knows. I joined company 1, they were doing it. I joined company 2, they were also doing it. So I realized this is just a pattern that happens. How expensive is Redis? You can start, I think, I could be wrong on this, let me Google this, but I think Redis runs on single core, which means you can run it on it runs itself is single threaded, which means you can run it on a very cheap machine, and it scales very well to like 1 million requests per second. Okay, 2 more minutes. When you say workers, are these Linux machines? These are Linux machines. Why say they are Docker containers? Like eventually when we reach Kubernetes, if you're really building lead code, you probably want them to be Docker containers, but they can also be EC2 machines. Yeah, they're VMs. Redis is no longer open source free. Yeah, there's some controversy that's happening. I haven't looked at it, but yeah, something is happening there. Make a PR SSG for, so how to get assigned the issue? Just contribute. Create a PR, dude. This is one project you can, don't spam with readmes, but try it out. I will close it worst case. Don't feel bad. How two different backends access same Redis if it's in memory of a different machine? Good question. This is EC2 machine 1, which is running backend 1, and then EC2 machine 2, which is also running the same backend. You have auto scaled backends basically. And then this is EC2 machine 3, where in memory Redis is running. Here in memory Redis is running. It's not running in memory on this machine or this machine. It's running in memory on this machine. That is why these guys can access it. Okay, 1 more minute. So you're using this architecture only while building lead code on YouTube. We were never able to reach building lead code architecture on YouTube. We are now building it here on projects on 100xdevs.com. This is the architecture that will be followed. Where is Q stored? Again, on a EC2 machine. Everything is on, a VM. Q is nothing but, in the end, it's all Redis running, which lets you do queues. Or if you're using, something else, you're using RabbitMQ. It's just a process running on a machine that is maintaining a queue for you. It's all running on an EC2 machine. Usually it will be on a separate EC2 machine. If this is your backend EC2 machine, you will have, RabbitMQ running on a different machine. Size of queue matters in what? What does in-memory data mean? How does Postgres save data? In-memory data means, the process that is running. If you are running a Node.js process, if there's a variable A over here, that variable is in memory. It means it's currently in RAM. If you remember the architecture, it's sort of in CPU right now. Not CPU, it's in RAM. It's in random access memory, which is, very frequently and easily accessed, very expensive. You only have 8 GB RAM. You have 1 TB SSD. Why? Because this is very cheap, but this is very hard to access. If you store data here, it takes time to fetch that data. If data is stored in RAM, you get it immediately. What is the downside? Downside is, your other question was, where does Postgres store data? It stores data in disk. Yeah. Unless I'm very mistaken, it does store data in disk. And whenever a request comes, it'll get that data not from RAM, but it'll get it from, your SSD, somewhere in that folder. If you remember, how did we start MongoDB? We said Docker run. I don't have it right now, but if you remember, we ran Docker run, we had a volume, /data/db mounts to something. This /data/db is where Mongo dumps all of its data. So it's stored on the file system. What's this? Redis is stored in memory. Okay, I think we're at 8:02 now, so I should start. Snapshotting thing again, how data is persisted in just Google read, but high level is forget append only file. Let's keep it very simple. You just take a snapshot of the database every few minutes. You dump the database every 900 seconds, or let's say 60 seconds, or every 300 seconds. Okay, by dump data, backup data. If there is something happens in this 60 seconds, then you're screwed. That data gets lost. If you don't have append only log, then you can just have a snapshot every few seconds, every 60 seconds, every 30 seconds. And if there is some data that gets, if it sort of broke between 2 60-second intervals, then this much data will be lost. But that is fine. It's not a lot of data. You still have a snapshot from very recent snapshot. But if you want, literally no data gets missed, then you need a append only file log. You need a log of every event that happened. Cool. All right. Let's do a poll again. I think I've answered a few questions. Hopefully things feel better now. But either way, I think we will proceed and write some code next because it's 8 already. And code writing is fairly straightforward. All right. 92% is great. Let's move on to writing some code now. First thing you have to do is start Redis. This is similar to starting Postgres. This is similar to starting MongoDB on your machine. You can either go to Redis, documentation and install Redis on macOS. You can totally do this. You can do a brew install Redis. Same for Windows or whatever. Or we have learned this many times now. You can run Redis using Docker. This is usually the standard port on which Redis runs, which is why the port mapping is from 6379 to 6379. Run it in detached mode. You don't have to give it a name. Feel free to give it a name. But what are we running? We are running Redis. Let's copy this. Let's open a terminal. Let me kill everything I have currently. And let me rerun Docker by running this command. Now it will work for some of you, might not for some of you, depending on your Docker configuration. It might take a long time for some of you because you might be fetching the Redis image. So either way, try to run this. And for me, I will have to change the name because there is one that already exists with this name. Docker run -- name, give it a random name. You don't have to give it a name here. You can remove this completely. In detached mode, which means run it in the background with this port mapping. What are we running? We're running the Redis image. If I do a Docker PS now, it tells me, Harkirat, on your machine, port 6739 is serving Redis to the port 6379 on the Docker container. This is starting Redis. What does Redis let you do if you remember from the beginning? Redis is an open source in-memory data structure store used as a database, cache, and message broker. We understood it is used as a cache. Chalo, it can be used as a database. I shared there is a video that you can go through if you want to understand how you can use it as a primary database as well. But message broker is interesting. What does message broker mean? It means the two things we discussed initially. Messaging queues as well as pub subs. Redis lets you run both of them. That is what we'll focus on today. We'll understand how you can use it as a database or cache as well, but we'll focus on messaging queues. After you run this command, you have to run one more command. See, we have started Redis. If you run the first command, which is docker run, Redis with this port mapping in detached mode. After you run this command, on your machine, if this is your, Mac machine, then you have Redis running in such a way. Here, any request that's come to 63, whatever the right port is, this might be the wrong port, is being forwarded to a Docker container that is running Redis. On, the port here is also 6739. You get the idea. The problem is, how do I talk to this? Let's say I started very similarly. I started Postgres. If I started Postgres on my machine, very similar using Docker, how would I talk to it? How would I send an insert request there? How would I send a delete request there? I would create a Node.js process. I would use the PG library, or I would use Prisma. And I would give, this Postgres URL to it. And it would be able to send a create, a delete, an update, so on and so forth. This is how I would do it if I was using Postgres. Do you remember PSQL? I shared you can use the PSQL CLI command line interface to also send an insert query ke bhai, insert into users something, or delete from users, so on and so forth. PSQL was if you remember, command line interface. Harkiyat, what is a command line interface? Something you can run here in your terminal. If I run PSQL here, it gives me something. Connection is not correct because I haven't given it the right username, password to my Postgres database. I don't even have a Postgres database running, but it is nice to have a CLI that talks to Postgres. So I can directly run commands in the terminal. I don't have to start a Node.js process. We will of course eventually start a Node.js process. But before we get there, let's try to interact with Redis via CLI, via a command line interface. Harkirat, so you are telling me I need to install something on my machine now. You will tell me to install some Redis -CLI, very similar to PSQL. Yes, ideally you would have had to install this, but thankfully, whenever you start Redis in a container, this already has Redis CLI inside. This already has Redis CLI inside. You can just go inside the container and run Redis-CLI and talk to Redis. You don't have to install it on your Mac machine. Can you install it on your Mac machine? Yes, you can. You can install the Redis CLI on your Mac machine, but why should you? It already is in this container. Why not go inside this container and run Redis CLI directly there? Harkirat, how can I do that? If you remember, you can go inside a container by running the docker exec -it, which means interactively container id /bin/bash. If you run this command, you'll be able to go inside your container. I have a container running. I want to go inside. What does going inside mean? It means I want to run bash commands. Nothing else. It doesn't mean I'm not going inside the Docker container. I'm just running bash commands on that Docker container. How can I do it? Docker, first run docker ps to get the ID of your container. Then run docker exec -it, which means interactively the container ID /bin/bash. Run this command to go inside the container and then run Redis-CLI inside the container. Once you reach the container, run Redis-CLI. Reach this point and then we will proceed. What have I done? Started the container by using what command, Harkirat? I used this command to start the container. Then I used this command to go inside the container. Then I ran Redis-CLI. It already exists in this container. And I'm seeing something like this. Now I can send it commands. If this was Postgres, I could have written select star from something. This isn't Postgres. So of course, SQL won't work over here. Something else will. But have you reached this point? Take 2 more minutes. Try to run it locally. Then connect to it locally using Redis CLI. If you want to go down the fancy route, you can also, install it directly on your machine. You can download it from source code. You can build it from source code. You can do this basically. If you want to, if this doesn't work for you, you can also download it from here, unzip it, and then you will find Redis server and, or you also have to make it. You need to have C++ on your machine, which is why, this is just easier. You can still follow this. I'm happy to post this if you want to directly install it on your machine, but it's just easier if you use, a Docker container. How many of you are able to run this much locally? How many of you are able to interact with your Redis instance that you just started? Oh, well, most of you are. So great. It was 90, then it reached 84, 85-ish. I think that's decent. Cool. So now the question comes, let's make Redis, do some magic. What did Redis say it can do? It can store data and it can act as a message broker. Let's start by storing data in it. The way to store data in Redis is give it a key, for example, user, and then give it a value. I don't know what is happening here. Value could be, Harkirat. Eesh. Something is happening here. But if I press enter, this is the command that I ran. Set user Harkirat. It's like storing a key value pair. I just stored a key value pair over there. Here the value of user is Harkirat. If you were using or storing using Redis as a cache, I would have stored something like this. Set tracks of whatever tracks exist on project.sonidexdevs.com. So unfortunately you can only store a string over here. You cannot store an object, but you can always store an object as a string, right? You can always stringify it and store it. So I would have stored something like this. It is an array. The first one of which is TypeScript. So title TypeScript, comma, description, whatever this description is, so on and so forth. This is how I would use Redis. Of course, this set would happen via a Node.js process. This wouldn't happen in a terminal, but this is how I would cache data if I was using it as a cache. If I was using Redis has a cache. I can set data like this. How can I get data? Can you guess? Get tracks. It gives me, okay, these are the current tracks that you have. And as you can see, it was pretty snappy, happened pretty quickly. I can also delete tracks. And now if I try to get tracks, it says nil, which means nothing got returned. That's a brief of setting data. Probably the simplest thing in Redis. It lets you set, get, and delete data. Very similar to a database. So nothing new over here. Only, this isn't SQL. There are no tables. There is no structure to your data. That if you want to read through, this video is exactly that. This video is what I call over engineering. Okay, just because Redis can be used as a database does not mean you should. I think this video is satirical also from what I remember. I could be wrong. But they say if you really want to use Redis as a database, you can. But you will see how, complicated it gets. So feel free to look at this video. One more thing I will quickly introduce, which if you don't understand, it is fine. Sets and gets are good enough, is hash set and hash get. If you want to store, multiple things for a single key, okay, bhai, user :100's name is John Doe, email is this thing, and age is this thing. If you want a more SQL-like structure, okay, user with ID 100 has, these things. If you want to associate multiple data or like multiple things with the same key, you can use hset, which means hash set. Set on the hash, okay, the user with ID 100 has this name, this email, this age. In the future, if they have an address, this address, so on and so forth. Here you can set just one thing on a key. Okay, for tracks, it makes sense. If we have a very long array of tracks that we cache for projects on 100xdev.com, so it's fine. We don't need hset. But if you want to use it as a database, you will need hset. If I copy this and paste it, you will see it says integer 3. It says I've set 3 things. I've set the name, email, and age. Now if I do a hget user :100 name, it says John Doe. Address, address doesn't exist. Email, so on and so forth. So hashed get basically means create a hash map for this key, create an object for this key. Name is John Doe, email is something, age is something. You can add more things. So hset user :100, you can be like address or city, Delhi. Now it has 4 keys. I can do a hget user 100 address, so on and so forth. So if you want to store complex data, you use hset. If you want to store simple data, which for example, caching could also be in a way that this website is built in a way that the people who have paid see some tracks, the people who have paid for DSA see DSA tracks. So it might be user specific. In that case, then also you don't need hset वैसे. Then also you can do something like this. Okay, set tracks for the user with ID 100. So you can do set tracks :100 as this. And then whenever user with ID 100 comes, you can do this, get tracks 100. Because it might happen, this website becomes user specific. The tracks become user specific. Who have paid will see something, not paid will see something else, so on and so forth. So that's gets and sets. Not really needed today, but a thing you have to introduce if you are doing Redis. Do we understand gets, sets? We haven't done it using Node.js yet, but do we understand it, using the CLI? We do. Very simple. Then the next organic step is how to do it using Node.js. Oh, fucking A. Very easy to do it using Node.js. Yeah, we'll see it eventually, but let's, not do it using Node.js. Let's do queues using both CLI and Node.js. Because if you understand how to do queue via Node.js, you can very easily understand how you can do sets and gets via Node.js as well. So let's understand Redis as a queue. Let's build a system like this. Okay, a browser sends a request to a primary backend. Backend puts it in a queue. Workers pick it from a queue. So we have to write the code to number 1, this code right here, a primary backend in Express. Number 2, we have to write worker code. That's it. We can send the request from Postman. We don't need to write any client-side code. But we have to write two Node.js servers. A primary backend that pushes to a Redis queue, a Node.js worker that pulls from the Redis queue and, processes the thing. Redis has a queue. You can also push to a topic or queue on Redis and other processes can pop from it. That is what we want, right? We want one process to push, other processes to pop. Good example of this is lead code submissions that we need processed asynchronously. Let's understand how you can push and pop using CLI. Once you understand this, in the next slide, we will actually build this and, write some Express code and, Node.js code over here. The way to push to a queue in Redis is this. Here the queue called problems. I am going to push, let's say 1 over here. Of course, you wouldn't push 1 when the user comes and, gives you all of these things. You will most probably put all of this data in the queue because you want the final worker to know, okay, problem ID 1 ka code, this has been submitted by this user, so on and so forth. So it won't be as simple as this, but just to start, let's understand what L push means. What does L mean over here? Push, I understand. What is L? It means push from the left side. As you push more and more things, they'll get put here on the left side. Harkirat, we should use R push. I want first thing to be pushed here, then second thing to be pushed here. It doesn't matter. The main point is if you're pushing from one side, you need to pop from the other side. If you're pushing from the left, make sure you pop from the right. Yeah, otherwise it will become a stack. So if you do a L push, make sure you're doing a R pop. If you're doing an L push and you do an L pop, you have a stack. You don't have a queue. Because if I push something if this is my queue, and if I'm pushing from the left, first thing I pushed is 1. And then second thing I pushed from the left is 2. And the third thing I pushed from the left is 3. Where should I pop from? Should I do a L pop? No, I should do a R pop. I want 1 to be picked up first, then 2, and then 3. So this always gets confusing. If you want to create a queue, if you're pushing via L, pushing from the left, pop from the right. If you're pushing from the right, pop from the left. And if you want to create a stack, then L push and then L pop. Let's see this in action. Forget the database. Forget setting data. That doesn't conflict with this. This is queues. Push to problems 1. 1 is a very weird, payload to put over here. What should we ideally put? Something like this. Like a JSON object that says, problem ID 1, user ID 2, so on and so forth. A bunch of data here. This is what you should ideally push. Even though this looks like an object, it's actually a string. The Node.js process will be able to parse it as JSON later on. But Redis doesn't support JSON. You have to store a string. So we have, a JSON.stringified string. I have pushed twice. How can I pop? Now what will pop in the real world? The worker will pop. But just to try out here, if I do an L pop, L push tha to R pop, problems. What am I missing? Oh, sorry, I exited out of the CLI. R pop, problems. I get 1 first. 1 was the first thing I pushed. 1 is the first thing I popped, very similar to what I showed here in Accelerator. If 1 was the first thing that got pushed, 1 was the first thing that should have gotten popped. What was the second thing I pushed? This thing right here. If I do an R pop problems again, I see the problem IDs over here, which means, and if I do it again, what happens? It says nil. The queue is empty currently. This is how you push and pop. Do we understand push and pop via CLI? If we do, then, we can move on to the Node.js code. There's one more thing called BL pop. But if you understand this only, then we should move to that. We do understand this. The last thing that's left is blocking pop. A lot of times you want I want to wait for when something comes here. I want to block the thread until something comes to the problems queue. So let me open another terminal here, docker ps, and then, docker exec-it/bin/bash. And here, if I do select, what am I doing? Redis-CLI. I have 2 Redis clients. I will produce from this one. I will subscribe on this one. I will do a BL pop problems. I repeat, not L pop. Blocking lpop, sorry, has to be rpop, my bad. Blocking rpop problems. And from here I will do a l push 1, let's say, or problems 1. If I press enter in the left terminal, oh sorry, I also have to give a third argument here. I will share what this third argument is. For now, let's just select 0. You will see it is blocked. It doesn't let me do anything. It is saying, bro, I am blocked until someone pushes on this queue. And if I push on this queue, you will see the blocking went away. So what does brpop problem 0 do? It says, bro, I am going to be blocked for an infinite time. That was 0. That's what 0 means. Okay, I will be blocked for an infinite time until someone comes and pushes something. Until then, I will just wait. Harkirat, what if I make this 5? It means I'm going to wait for 5 seconds. 1, 2, 3, 4, 5. Nothing happened. It exited. It said, bro, sorry, nothing came. 5 seconds passed. So usually you do 0 over here. We will do 0 in our final process. And whenever something gets pushed, the blocking goes away. You're able to get something here. Cool. That is what BL pop is, or BR pop is. Hoping it's straightforward. And not going to do a poll now. Let's move on to what? Let's move on to implementing this first part of LeetCode in Node.js. If we implement this, I think we're good for today. I don't think we'll be able to do more. What's left is pub subs. I'll cover in an offline video. We'll cover pub subs and then, the code of Node.js in pubs. Basically the second part over here. What we're covering today in the live class is this code. What we'll cover in the offline video is this code right here, even though a lot of this, sorry, not this code, this code. A lot of this second WebSocket part was left as an assignment. So I had to either way do it in an offline video. But let's first, talk to Redis via Node.js. Let's do the same interactions we did via CLI via Node.js. Very simple. You use the Redis library. What is the Redis library? What is the Express library? Lets you create HTTP servers. What is the Axios library? Lets you talk to an HTTP endpoint. What is the PG library? Lets you talk to a Postgres database. So what is the Redis library? Lets you talk to a Redis database. Let's write the code just for this primary backend that pushes onto a queue. Let's not worry about the worker code today. I'll just create an offline video for it soon. Okay? Even though it's right here, so you can feel free to copy it. All right. So ideally you should create 2 folders. Let's just do it. Let's just do both of them. Let's write the primary backend. Let's write the worker code, and let's try to publish here, subscribe, or push to the queue, pop from the queue, and see if it works or not. Create an empty folder, and inside this create 2 another folders. I repeat, single empty Node.js folder inside which you create 2 folders, one called Express server, one called worker. Let me do a poll because this is a very simple code. Do you want me to I already have the code locally. Should I just explain the code? Yes or no? If you select no, then we will write the code together. But should I just explain the code? Yes or no? If you select no, then I will write the code from scratch with you. Yes. I'm in very close competition here. It's almost a 50-50. So we can write it. It was a 50-50. Okay. Create an empty folder inside which you create 2 other empty folders. I will do it fast though. So what did I say? Let me exit out from everywhere. You can exit out from the CLI. You don't need it anymore. We will be now interacting via the Node.js process. Create an empty folder, call it week 19, LeetCode clone or whatever you want to call it. And here create 2 folders, call one worker, call one Express backend. Open this in Visual Studio Code. You can call them like something else as well. The name doesn't really matter. All right. Going to give you guys maybe 15 seconds. Create 2 empty folders, nothing too fancy, very simple stuff. 2 empty folders that don't have anything. Open it in Visual Studio Code. 10 more seconds, then I'll proceed. Sorry, one more second. All right. Next up, what do? You initialize empty package.jsons, tsconfig.jsons, done many times, not going to repeat it. I'm going to go to the first folder called express backend and run these two commands, npm init-y, npx tsc-init. I'm going to go to the other folder, run the same two commands, npm init-y, npx tsc-init. If this doesn't work for you, you can copy over tsconfig.json from a random project on 100x devs code to GitHub. You'll find a TypeScript project, just copy over tsconfig from there if npx tsc-init doesn't work for you. What is the next thing we do? We go to tsconfig, we change the root dir to source, src, we change the out dir to dist. Done this many times, hoping it's straightforward. Going to wait for 10 more seconds. What did I do? These were the two commands I ran in both the folders. Now both the folders have package.json and tsconfig.json, and I changed the root dir and out dir here also. What's the next step? Create source/index.tsn, both the places. Source index.ts, source index.ts. All the steps are present here as well. Do these two things and then maybe ignore this and this for now. Just create a source/index.ts in both the folders. Going to wait for 20 seconds and then I will proceed. This is what my folder structure looks like right now. Yours should look the same as well. If you want, feel free to install these dependencies as well. Make sure you're installing the right dependencies in the right folder. Express server, only this one needs Express. This guy does not need Express. So make sure only here you're installing Express. Five more seconds. All right. Now let's install the dependencies. The worker needs a single dependency. What does the worker need to do? It just needs to pull something from Redis and do a fake processing on it. We are not writing the code to actually run the end user's code. That will come once we reach Kubernetes. We're not writing the code to actually run the end user's code. We are just writing the code to pick and then maybe run a fake timer of 1 second, processing code, and then sending back a accepted to the user. So this only needs one dependency, the Redis client. So in the worker, all you have to do is npm install Redis. But the primary backend needs to do two things: expose an HTTP endpoint, which means it needs Express, and also needs to push to a queue, which means it needs Redis. So on the Express backend, npm install Express at types/express and Redis. Cool. Now comes the part to write code. This guy needs to have a single endpoint. You can also copy this code. I'm going to write it from scratch. Import Express from Express and import create client from Redis. This create client lets you, well, as the name suggests, const client equal to create a Redis client. And then, on this client, you can call client dot, what was it? lpush or lpop. So it's pretty much that easy. You just have to create a client. There's one thing I'm missing. You also have to do a client dot connect over here. Ideally, you should await this as well. You cannot await on, the global thread over here. So if you look at the final code over here, that's a little more cleaner. If you look at the final code over here, we have a start server function, inside which we first await client.connect. Make sure the Redis client has actually connected. and then we listen on the Express port. So this is the right way to start the Express server. First, make sure you are actually connected to Redis. Otherwise, someone might send a request and you might not be connected to Redis itself. So, it'll become a problem. So this is the right way to do it. I'm just going to, wing it right now and, hope that the client.connect happens before a request comes from the user on the app.post submit. Let me write the rest of the code. Const app equal to express, app.use express.json, and then app.get or whatever, post /submit const, whatever problem ID, user ID, and code, maybe language, all these things the user will send me equal to rec.body. And what do I have to do? Ideally, I should push this to a database. So I should do, prisma.submission.create. We don't have any Prisma schema yet, which is why I'm not doing it. But ideally, you should store it in a database as well. And what else do we have to do? Client.lpush submissions. Client.lpush to the submissions queue. What does the first argument mean here? The first argument is, I close that. The first argument is, whenever we are doing a push, if you remember from a few seconds ago, whenever we were doing a push, I did a lpush problems, and then I gave it, some object, ID 1, so on and so forth. So this problems, the name of the queue is the first sort of argument. The second argument is all the payload. I've taken all the payload from the user, dumped it over here. That is all that you have to do. Rest.json message submission received. This guy is publishing to the queue. We haven't written any worker code. No one is consuming from the queue, but at least, publishing side is done. How can I confirm if it is working? And for this code, as you can see, is less than 18 lines of code. If you look at this code, it's slightly more because it has, the start server logic to make sure the client connects first. This also looks very fancy the way I've extracted it, but it's pretty much very similar code. The way to make sure it works is I will do a tsc-b to actually compile my TypeScript code into JavaScript. You can also copy this code, paste it here and compile it because both the codes do the same thing. And then node dist/index.js to actually start the Express server. How is it starting? Considering I haven't done a app.listen. App.listen 3000. Yeah, I forgot that. tsc-b. Yes. Now I'm listening on port 3000. Let me try to send a /submit via Postman. You should send, whatever. If you've copied this, then submit is the same, but the arguments are a little different. So make sure you send the right arguments. They're actually pretty similar only. All right. Local 3000 /submit. Yeah, pretty similar-ish arguments. I think user ID is one thing that's missing here. Send, and it says submission received, which means what? Control reached here, which means what? Most probably this has succeeded. This is an asynchronous operation. You should ideally await it. Or, this will probably be have a callback at the end. I'm sure there's a way to, await it. lpush type of what is the exporting by default? See, do we have something here? Await. You can await it, right? Oh, okay. I was not able to await it because async. There you go. So you ideally should await it. I mean, if you don't await it, then it might happen that nothing reached the queue. You still send the user, this thing. So you should ideally await it. You should ideally put this in a try catch. Only if it succeeded should you send the user this. Else you should send the user submission failed for whatever reason. Failed. So you can make it as fancy as you want, or catch. But yeah, if I restart it, compile, no decisions, go to Postman and send data, it says submission received. Question is it actually pushing something to the submissions queue? How can I check? How can I check? Okay, anytime the endpoint is being hit by Postman, something is reaching the queue. How can I confirm this? I'll just go to my terminal, do a docker exec. Do a redis-cli, do a rpop submissions, because submissions was the key of my, when I was doing an L push, where was I pushing? To submissions. So where am I popping from? Rpop submissions. And I see problem ID 1, user ID 1, code something, language something. Pop again, I see it again. If I do let me clear the queue. Now let me do a BR pop. Okay, I will remain blocked until something comes over here. BR pop submissions 0. And as you can see, it is blocked, and it will remain blocked until I send a request from Postman. So it is blocked right now. As you can see, this is, not exit out. If I send the request, you will see the submission came over here. So we are able to populate the Redis queue correctly. We have confirmed this. The worker logic is pending, but do we understand this part? Sending data to the Redis queue. I'm assuming it's pretty straightforward actually. Great. So let's write the worker code. Worker code में क्या है? It's as simple as going to worker, doing an npm install of Redis, opening worker/index.ts. And what does this guy need to do? It also needs to create a client from Redis. That is the first thing this guy also needs to do. But after it has created the client and after it has connected, what does it have to do? It needs to infinitely keep hitting, keep doing something again and again and again and again and again until pretty much infinity, until you stop the process. It needs to keep blocking and waiting for other people. What do these workers do? When you start these workers, they are just polling the queue. Do you have something? Do you have something? Do you have something? Achha, you have something, give it to me. I will run it. And then, whatever, do things afterwards, send it to a pub sub. But, they infinitely need to keep polling the queue, which is why you can put a while one here, infinite for loop, doesn't matter. And do, here you probably want to await the client.connect because, the while loop will immediately do a, client.rpop submissions, and you don't want that. I think I can just await this as well. Const response equal to await client.rpop. This, I just need to put it in an async function because I'm doing a bunch of await calls over here, and I can do this here, and I can call it main. Now I've done a few things here, nothing too complicated. I just called the main function, which is asynchronous, inside which I first awaited कि भाई client.connect हो जाए. Let me first connect to the Redis client. Once I do, then I'm just getting the response. Then I can, here I will actually run the user's code. We don't have any of that logic yet. We are not writing the logic, even though it's very similar. Very simple. You can do a docker exec over here. If you want to build a janky version of it, just run the user's code in a Docker container. We're not going to do it, but yeah, we'll just do await new promise, resolve set timeout. Harkirat, what does this line do? You have introduced a very weird line. It just, awaits for 1 second. How, Harkirat? What does it say? It says await a new promise, which will be resolved after 1 second. Harkirat, very complicated syntax. Put it in ChatGPT. It will tell you how it does it. But this is similar to simulating an expensive operation, similar to awaiting for something that's taking more than 1 second, awaiting on it, not blocking on it. Your thread isn't blocked here. Still do other things. There is nothing else in this application. It's just doing this. So, it'll just await, but you get the idea. We're just simulating running the user's code. And then, here we should actually ideally send it to the pub sub. We'll cover that in the offline video. And then, we can log processed users submission. That should be pretty much it. The final code, if you look at it in the slides, start worker does a client.connect, logs worker connected to Redis, while true, get set from the submissions queue. Oh, I need to pass in another argument here. The timeout, so submissions, 0, await client.brpop. Yeah, let's do a brpop. Let's wait for, let's keep waiting here until you actually get back a response. If we don't do a brpop, this response will be null from time to time. And, we'll just keep running this loop versus let's just await. Let's just do a blocking brpop, right? Pop, but stay blocked over here until you get something. And then, process submission, which here, just does the same thing. Extracts the data from the, you can probably also, console.log response to actually see the thing that was put in the queue, the thing that was actually put in the queue. Let's log that over here to see what it looks like. Cool. Let's compile the worker code. Let's run it twice. I repeat, I'm going to run the worker maybe more than twice. Let me run it 4 times. Because in the real world, you will have multiple workers because your website could have 100 users. So let me open the terminal. Let me split it into 4 windows and let me go to this worker folder and run 4 workers. cd node disk/index.js. Run the same thing here. Node disk/index.js. I'm starting 4 workers on my machine. And now all 4 of them are waiting. Okay, when will something come in the queue? Let me put something in the queue. How can I do that? I will start the Express backend as well. Node disk/index.js. And I will start sending Postman requests. So let me put this on the left, the 4 workers. Let me put Postman on the right. Let me start sending requests. As you can see, they are getting picked up by random workers as time goes by. And they are processing all the submissions. What if all the workers are down? What if all the workers are down? It is fine. They will keep piling up in a queue. And as you can see, more and more people are sending submissions. It's fine. They are waiting. Your workers are down. But you can always bring back up workers and they'll start processing the code again. So that is the benefit of such a asynchronous system. Okay, if the workers are ever down, you can just bring them back up. They'll start polling from the queue, and then I can keep resending. These guys can keep repicking. That is how you build the first part of what we're building today, which was this architecture right here. What is left to be built? This architecture right here. I will cover in an offline video both what is a PubSub and how a worker can publish to a PubSub to a WebSocket server and pull it from there. All right. I think that will be it, guys. I will do a poll. Did you guys understand everything? And then we will open it up for questions. Great. All right, going to open chat. Feel free to drop off. The class has officially ended. Thank you everyone for joining. And if you have no questions, I'll see you guys maybe next week, because next week might be a holiday. We'll do a poll, and if people want a break before 1 to 100, we'll do a holiday. Else we'll continue. All right, questions. There you go. Oh my God, so many questions. Stop. Okay. Recap, please. Let me do a quick recap. Won't do very deep recap because 92-93% understood. I'm assuming that means it's pretty simple. What we learned today was queues, publisher subscribers, and Redis. Why did we introduce Redis? Because Redis lets you create queues, and Redis also lets you create PubSubs. Question is, what are queues and what are PubSubs? Queues, as the name suggests, is a queue where one Node.js or Golang or Rust process can push something to a queue, and another, again, Node.js, Golang, doesn't matter. Any process can pick things from here. This message queue architecture is very popular when you're building a system like LeetCode. Harkirat, why is it popular in LeetCode? Because in LeetCode, you're letting the end users run an expensive operation on your compute. What is compute, Harkirat? Your machines. You're letting the end user run a C++ code on your worker. When you do that, you want to make sure you don't run it on your primary backend. You also want to make sure that I only have limited workers, 3-4 workers. If a lot of people send me data, I can't simply tell the workers do this, do this, do this, do this, do this. I can only push it to the queue and hope that the workers will auto scale eventually. If the queue is very long, they will become 20 workers and pick up and start to process them. That is why one use case of using message queues. What is the other thing we learned? Pub subs. What if a worker that has processed the user's code, what if they want to send the end user? Okay, bhai, there you go. Your submission was accepted or rejected. How can they do that? The worker cannot directly connect to the browser. The worker is very protected somewhere. When we run this, I might be, buying 3 machines and running the workers there. Why would I rent a worker on AWS when I know, it needs to run all day and 3 are good enough? So this thing can't directly connect to the browser is the point. These might be running in someone's home. These might not necessarily be running on an AWS machine. So what these guys can do is they can publish to a pub sub, which is running on the internet, running on EC2. Okay, bhai, please tell user ID 1 that something has happened. And the WebSocket server that is connected to user 1, in case the user is on the website. If the user is not on the website, great. But if the user is on the website, or more specifically, if the user is waiting on this page after submitting, what was my response? Was it accepted or rejected? I'm waiting. Then the user has a persistent connection to a WebSocket server. The worker can tell the WebSocket server via a pub sub, user ID 1 ko send this thing. So that is the general architecture that we learned today. We just learned a little bit of implementation of this as well. Can we implement Redis push in Next.js as well? Want to optimize my API project? You can, as long as you are doing it on the server. Just don't do it in a client component. It will not work. But if you're doing in a server component, it'll be fine. Is Redis queue equal to messaging queue? That is a good question. I'm being very cautious. What is a messaging queue versus queue? Yeah, I'm being very cautious of saying the word queue and messaging queue. Message queue versus message broker. I would assume queues and message queues can be used interchangeably. Message queues and message brokers are different things. But I think queues and messaging queues can be used interchangeably. Could I be wrong? Yes. So please Google this. Don't take my word on it. All workers are taking all the items in the queue, right? Only one should take it, right? No, not everyone is not taking only one is taking one item. If you look at the code, if one worker will pop, then BR pop, the other will pop a different one. Let me open the terminal. I have 3 running, right? I have 3 workers running over here. Let me open all 3. Let me restart the 3 workers. I have 3 workers running. Or even better, let's run 2 workers. I have 2 workers running. If I go to Postman and send, only one picked it up. Both of them did not pick it up. If I send again, only one picked it up. Both of them did not pick it up. So the code makes sure only one is picking it up at one time. Does this worker try to pick up the work? Yeah, so it's similar to this. Okay, a few people are feeling it. It's similar to if I open 2 terminals and in both of them I run, BR pop submissions and then BR pop submissions. Then, whichever one got there first will be able to snag the item from the queue and the other one will still have to wait. So, that's what's happening. They're not both going to get the same item. Topic related questions on Notion. Does okay, answer that. If auto scale the 4th worker, will the 3rd? Okay, a lot of people are asking the same question. The answer is Redis will make sure only one item is able to, or one worker is able to pop. As long as one pops it, the other one will not get the same thing. Abhishek, if I answered that, all work answered that. Can we implement answered that? Okay, same questions again. Worker code repeat. I will go through worker code. One more time. Break please. Bas break here, bhai, chutti ab. Are there limits of Redis cache to store data? There should be. I'm sure there is a limit. Redis hset limits. Redis can handle up to 2 to the power 32 keys and was tested in practice to handle at least 250 million keys per instance. Every hash list can store up to these many elements. So your answer is right there. You should learn to Google, by the way. Most things you ask me, even I don't know the answer. I will Google in front of you. Can we implement this Redis? Okay, answer that. Worker code repeat. I will repeat worker code. Let me answer all the questions and I will do it. Trying to answer questions only related to the class. Why Redis queue? Like, why can't we create queue the way C++ DSA problems? Good question. Question bhai is asking, okay, Harkirat, why have you done this? Very bad. We come from the DSA world. Why are you doing this? This is an EC2 machine where you are running a Node.js process. And this is pushing to a queue in a different EC2 machine, or maybe the same one, doesn't matter. But a different process it is pushing to. Why do you not create a queue like we do in a C++ process? The queue in a C++ process is in memory. It is a variable in your Node.js process where queue equal to empty queue. How will another Node.js process that's running somewhere place else get access to this queue? It cannot. It's in memory over here. I mean, it can technically, but it can't. A different machine though it cannot. That is why you have a second process whose job is to maintain a queue so that this guy can pull things from here. If you put it in memory like you do in C++ when you're doing algorithmic problems, other processes don't have access to it. When you're solving C++ problems, you have a single process. When you're doing a lead code problem, you have a single C++ process, right? You don't need another C++ worker process to get access to this queue. But here we do. So you cannot store it in memory. You store it someplace else. More specifically in, a messaging queue. That hopefully answers your question. Worker code repeat, a lot of people were saying, or one person was saying again and again. I don't know, one of the two. So let me do that. Let me repeat the worker code one more time. As you can see, thankfully, not a lot of lines of code. We create the client. Actually, okay, I get why it might be jarring. Let me see if I can make it slightly better. I cannot, can I? I can make it better like this. There you go. This is as good as it gets. I just call a main function. And inside that, I run all of this logic. Harkirat, why? Why can't you do this? I cannot do this because you cannot have an await at the top level. And hence, I just copied all of this logic, put it in a main function, and then called the main function over here. I create a client, a Redis connection, I connect to it, and then I infinitely run a loop. Okay, bhai, is there any response? And as soon as I get a response, I just log it for now. Eventually, I should actually execute it. I wait for 1 second. If you don't understand this, but remove this line. It doesn't matter. Eventually, you'll have some, Docker orchestration here. And then you log something on screen. So that is the worker code. It's actually pretty straightforward. Chat went away somewhere. Okay. Let me open chat one more time, guys. Oh, there were a few Notion docs also. I will look at them very soon. But any more questions? Okay, a lot of questions. But if you integrate Redis with Docker volume, then will the data be lost if something went down? No. If you integrate with Redis volumes, as long as you're mounting the place where the append only log is stored, you'll be fine. You can most probably, like 99%, you can persist data if you have the volume mount to the right place. What do I mean by the right place? The place that has the snapshots stored. As long as you have volume mounted there, you'll be fine. How BRPOP makes sure that only one worker will pop the task? Do you remember when I said Redis is single threaded? What does that mean? That means wherever Redis is running, if this is my Mac machine where I'm running Redis currently on, inside Docker, this is running on a single core. So if two people do a BRPOP, bhai, I also want to do, Redis can only process one at a time. It is not running on multiple cores. It will first try to process this, and if it returns this guy something, second I will not get it. It cannot parallelly handle both of these requests. It runs on a single thread, which is why. Oh, am I sharing my screen? I am not. I was saying, if this is my Mac machine and I'm running Redis over here, and there are two people who have done brpop, then both of these people, Redis cannot process both of these requests together. It's probably catering to this and then catering to this and then catering to this, flipping between them. And then when it gets some item, if something gets pushed, it'll just send it to one of them. It cannot parallelly handle both the requests. It is running on a single thread. Run sequence. Harkirat, Redis runs on a single thread, it'll be slow. No. Thankfully, even though Redis runs on a single thread, it is incredibly fast. As fast as it can get. So, that's never a problem. My chat went away. I have to stop sharing it. Okay. Chat app project looks pretty good. What will happen after we pop our worker goes down? Yeah, that's a problem. That's a good question. So there you do acknowledgements a lot of time. That is a very good question. The question is, I missed this. Okay, Harkirat, what if you pop and then this goes down? You were not able to process. You popped it from the queue became empty, and then you weren't able to, actually solve the problem or, actually process the user submission because the Node.js process went down. You can add an acknowledgement to a queue. I'm pretty sure that Redis lets you do. Redis queue ack. Pub sub ack knack. There is a way to do this. I think there is a way like in Redis to do this by default. If not, you can implement it yourself as well. But okay, here's how you can implement it from first principles. Even though I think there is a way to do it in Redis, I'm happy to Google after the class and let you know. This is your queue, right? What can you do? I mean, I have a few ideas in my head, but all of them will have one case where it will break. Basically, if this question was asked to me in a system design interview, I would have failed. This is your queue. And in this queue, the one thing is, you can have whatever queue you have. If there is a Node.js process that is picking from that queue, it can be like, bro, I will take something. I will take something from this queue. But if I don't respond back in the next 5 seconds, I repeat, if I don't tell you back in the next 5 seconds, I am done, your process is done, then please push this again to the queue. I repeat, if you can have some sort of acknowledgement on every item, whoever is picking it, it's their responsibility to acknowledge back in 5 seconds either the submission was done, or if they don't acknowledge back, then the queue can assume it failed and add it back to the queue, or mark this as not processed so that someone else can pick it. Question is, how can you do it? I thought you can easily do it. Some argument brpop will accept. Like while you're popping, in the end you'll do a br ack. Not exactly this, but I have a faint memory that you can do this in Redis. Does someone already know this? I'm sure someone in chat already knows this. No one knows this. Cool. No one knows this. I'll answer this question. I will forget this question, but I will still. But sorry about that. What was it? How to do acts in queues in Redis. All right. Cool. That's a good question, dude. Let me look at the Notion docs. Not loading. Why WebSockets can be in both asynchronous and synchronous? Depends on your definition of asynchronous and synchronous. If your definition of asynchronous is here, I will send and the other person might pick the thing in their own time, then it is not asynchronous. When you send data via WebSockets, you send it immediately. कि भाई रख ले. तो That is what makes it synchronous. But what makes it asynchronous? If you say that the definition of asynchronous is that whenever I am sending data, I don't worry about an acknowledgement. Whenever I'm sending data over WebSockets, I don't worry that the other side will send me something back. Then it is asynchronous. So the question really gets down to, what is the definition of asynchronous? And the answer is WebSockets, at least I think if you read online everywhere, it will tell you it's asynchronous because you don't worry about the response. Send it to the other side takes care of it. But I personally, was arguing it's probably synchronous. But I think if someone asks you in an interview, you say asynchronous. Suppose we clear Redis and then update Postgres. What if backend sends the request to Redis and Redis gets refreshed before the put operation in Postgres? Suppose we clear Redis and then update Postgres. Okay. What if backend sends request to Redis and Redis gets refreshed before put operation in refreshed? What does refreshed mean? Do you mean it gets cleared? Because if it gets cleared, you are fine. Redis is cleared. Redis has no data. And you're saying if the backend request came to update something and you sent a request to Redis, but in this process before the update happened here, Redis refreshed. What does refreshing mean? If refreshing means the data got cleared here, then you're fine because whenever the next get request comes, it will not find it in Redis and it will find the latest data from Postgres. If you mean when you say refreshed, it went down, then the answer for you is I told you whenever you're hitting the backend, you will first try to clear Redis. If this fails, you will tell the end user your request has failed. You cannot add a track. Only when the first clear happens, then update happens, then you tell the user you are good to go. If only clear happens, it's fine. Clear Redis got cleared. In the next get request, it will get filled. The problem happens when you put data in Redis and put data here. When you put data in both the places, is when if one of them fails, you'll have a problem. Hopefully that's clear. How does Express.js backend server is pushing to Redis queue? We haven't provided any URL. Oh yeah, good question. Yeah, you can provide. Yeah, that's a good question. You can provide, Redis URL somewhere here. Create client. There you go. Something like this. In our case, it just picks the default URL and connects to localhost. But if you ever get a cloud Redis URL, if you go to console.avian.io, you can buy a free or get a free Redis create service. Create Redis. There you go. Get one for free. Then you will have that URL. For example, I have this URL. Let me copy it. Then I can just, paste it. There's a way to just pass that argument here and then you're good to go. It might not be this, might be, something like more complex. Yeah. Username, whatever my username over here is. Let me reveal it, default. You get the idea. You can, pass all of these here. And then, that is how your client will connect to this cloud Redis instance. Good question. What if we run Mongo container 1 and bind it to the same volume for project 1 and run Mongo container 2 with the same volume config for project 3? What if I start one Mongo container, bind it to the same volume path for project 1, okay, and run Mongo container 2 with the same volume config for project 3? Do you mean what if I start two Mongo containers, mount the data directory there to the same volume? And the question is that the answer is they will just remain in sync. If the first container when you put data, it will appear in the second container, so on and so forth. Before start teaching, just cross-check layout. It always gets fixed when you reshared. Makes sense? Please do share Web3 cohort after 120. I want to join but can't cope up both simultaneously. We will see. I'm unsure when that will happen, but yeah, we'll see. All right, cool. I refresh the page, don't see any changes. Oh no, I see more changes. Oh, some. I use Postman request submission. Why can't see it in Redis CLI? It just me. You are doing a problems here. You're popping problems. Are you sure you're pushing two problems as well? When you do a L push, are you pushing to problems or are you pushing to submissions? That might be the only thing. Other than that, if you still see a problem, log this response, see what the response is, debug from there. All right, that's done. This one I'm not able to start. I've started this. Oh, there you go. We use queues to have processes in queue. Whenever the worker is free, it will pick up the task from the queue, correct? Redis is for caching data to make systems optimal, does not make it useful. So it does not make not so useful requests. It does not make duplicate requests. It does not make, if this is your Postgres, so it doesn't overwhelm your database with reads. If you want to, cache some of these reads in Redis, it's not useless information. It's just, protecting your database with, a lot of reads. And Redis has also queues thingy, which will save multiple incoming requests and process them accordingly. It also has the queues. Can you elaborate on this? Whenever client on website makes a GET request, primary backend will make a request to the database and send it to the user, push that data in Redis in database. So whenever I make the same request and DB did not change, it will go from Redis. Whenever the client on website makes a GET request, primary backend will make a request to the database, correct, and send it to the user and also push it to the data to Redis, correct. So when I make the same request and DB did not change, it will get from Redis, yes. But you usually add an expiry. You make sure that this data is cached for 10 minutes. Or you write your code really well so that whenever there is an update happening, you clear Redis as well. But ideally, you just add expiries. It's fine if one request goes to the table every 20 minutes or 30 minutes. So there is some expiry here. Isn't AWS SQS same as Redis? SQS, simple queuing surface, is the same as a Redis queue. Redis provides you a database. Redis provides you a PubSub. More things it provides you. SQS is simply a queue. SNS is similar to messaging queue, I guess. No. So SNS, even though I've not used it, my guess is it's more similar to a PubSub. It is a notification system. SQS, simple queuing system. SNS, I have not used it, but 90%, 99% sure it's this. Simple notification system. This is used for maintaining a queue. This is used for there will be a notification system. I will notify on a topic, even though again I haven't used this, so don't quote me on this. Do Google this. Okay, this does the same thing, but my guess is it does. I will put something on a topic and then other processes can consume from a topic. So SNS is probably more similar to a PubSub. SQS is more similar to a queue. Both of these we've discussed in Redis right now. All right. Cool. Let's do one more, guys, and then we'll call it. Right. Simulating lead code bit was great. With respect to materialize view question, we don't always recreate materialize view. Materialize can be upserted append only. Okay, that makes sense. Not fully refreshed. That is fast refreshes, where we only modified rows and appended. That makes sense. Don't get me wrong. I would love to understand Redis more work, but I'm trying to understand if the effort is worth it. Now even I'm trying to understand if the effort is worth it. If you were telling me when you create a materialized view, you can, even though I'm hearing this for the first time, you can only update, the updated views, rows can be updated in the materialized view. Would I use it? How does a materialized view help? Now I'm totally back to square one. How does it's not hitting the main database? You're getting data from a view in your database. Currently, we are using Redis at work to save total counts of get resources. I'm trying to understand if we should use it for other get endpoints or use materialized views. This is an interesting thing. Materialized views versus Redis caching. Let's see. I'm sure someone has had this, problem. This is a good question because of need. When I'd use Redis instead of Postgres materialized views. There you go. We have something. I'm not sharing my screen, am I? When I'd use Redis instead of Postgres materialized views. If I wanted to relieve Relieve load on my database server. Easier to scale Redis than to scale out RDBMS. This is what I was saying as well. It's still in your database, right? Even though it's a materialized view, your GET requests are still going to a database versus a Redis queue. Now, this might be too much of an optimization. Maybe you don't need it. If I wanted to cache something that isn't relational data from Postgres, so this is not a problem. If I was frequently writing this data, didn't need those to be ACID compliant, and I want those writes to be immediately available, then I would use Redis. When I'd use Redis, let me also post this in chat so you can read it as well. It is an interesting question that I have never thought of, or someone has asked me, but let me know what the answer is. I'm sure the answer is there on the internet. Oh, yeah. So yeah, all right. Yeah, but good question, man. Akhil Pator. Let me open some Notion docs here. Message acknowledger. Redis SMQ. Redis SMQ is a Node.js library for queuing messages and processing them increasingly with consumers. Backed by Redis, it allows scaling up your application with ease of use. What's new? This will probably have, some sort of acknowledgement. Minimal. Let's just see. Producer is a producer. Producer.run. Produce. Where's the consumer? Consumer.consume. Message acknowledgement. Once a message is received, to acknowledge it, you invoke the callback function without arguments. So this is how you can take care of it. Okay, you can use this project called. How often is this used? Not very often. I'm sure there's a better alternate. I mean, this doesn't look like it's used too much. But yeah, you basically need to build something like this where there is some acknowledgement of every message, and if the acknowledgement doesn't happen, it stays in the queue and can be picked by someone else. Am I sharing my screen? Sorry, my chat went to the other place. I have to keep doing this. Someone sent this Redis SMQ. Read about it. TLDR is whenever you create a consumer, whenever you have that final message handler that will actually do your lead code submission, you call the callback function that actually acknowledges this in the queue. Okay, the thing was actually processed, and if callback is not called, that means the message isn't processed, which means someone else will pick it up. So yeah, this is a good find. Now I will have to stop sharing screen again because chat went somewhere else. How is EC2 machine brought up automatically in the use case of load balancers? We can control how many EC2 machines are brought up. Yeah, just read about something called auto scaling groups. The name itself, auto scaling groups. ASGs in AWS, very simple to implement. Press a button, like give it a number 5, it'll start 5 machines. Give it a number 2, it'll downscale to 2 machines. You can also do it programmatically. So the easiest way is to use an ASG if you want an EC2 machine. When does someone subscribe to the PubSub after clicking the submit button or continuous connection? Depends. Good question. So, good question. Great question. In lead code, it's probably continuously. Initially, the person will be like, any event on user 1, please send me. But for a use case like this, it will depend on what page you are on. If I go to backpack.exchange, which is not working right now. Binance. Okay, there you go. If I'm on this view, then I want to be subscribed to all of these messages and this ticker and so on and so forth. But when I click here, I want to tell the server, okay, bro, please give me these updates. And if I'm back here, I want to tell the server, please give me these updates. So, that is how you move across. You change what you subscribe to based on what screen you are in. You have a single connection. If you look at all the logs over here, if you go to the network tab and, go to the WebSocket stream over here, it's hard to find it. There you go. You go to the WebSocket stream. You will see, notice the messages. Unsubscribe to something. Subscribe to something. As I change the view, I send to the backend, okay, bro, I want to subscribe to 1 hour data of this specific chart. And then, if I change the view from If I go to the bottom here and if I change the view from book to trades, you will see I send, I am subscribing to the trades on this market. So, you tell the WebSocket server, okay, bro, I'm changing, I want subscription to this. And now if I go back to book, then I will send a message that says, unsubscribe to this thing. And, subscribe probably was already there. So that is how you subscribe. You can, based on what page you are on, what layout you're on, you can subscribe and unsubscribe to events. And then the backend needs to handle, okay, it sends, the right set of messages. All right, cool. Let me take Notion doc here. Worker snippet this, worker connected to Redis. It is processing it, isn't it? Oh. Sir, what is happening is you are pushing and then the Node.js code is popping it. So you are not getting the time to see it in the CLI. The other worker is getting it. Stop your worker. If you stop this worker of yours, then you will see it here. You push and your worker pops it. So you are not able to pop it here. You are doing an RPOP. It's not as fast as a BR pop. BR pop is waiting. As soon as you push by postman, this guy picks it up. So your RPOP will not return you anything until you stop this process, or you do a BR pop here as well. So that, this also blocks, this also blocks. First one, this guy picks. Second one, this guy will pick. That's what the problem might be. Alrighty, guys. With that, we will call it. I will see you guys next week and in some offline videos. Oh, maybe not next week based on, if we might cancel it. All right. With that, let's end it. Let's see a few questions. My PC, one PC has 8 GB RAM. How many workers are running on my PC? The good question. Harkirat, my PC has 8 GB RAM. How many workers can I run? Depends on what SLA you have given to your users. When you go to codeforces.com, it says, okay, yaar, we are only, whenever you submit code, we run it on a 4 GB machine. So in your case, you can only run 2 workers. Whenever you're starting video transcoding, you can see the stats. Okay, on a 8 GB machine, it takes 25% CPU. So you can start 4 workers. So depending on, how expensive that operation is, you can scale up the number of workers or scale down the number of workers. Cool. Good question. With that, I'll call it, guys. Have a good night. Bye-bye.